Hello, everybody. Thank you so much for attending this presentation to learn more about how you can engage your municipal leaders in understanding about the hazards of PFAS, per and polyfluoroalkyl substances, and to test their drinking and their wastewater. Move Past Plastic is partnering with many different organizations to educate residents, businesses, and municipalities and the legislation about the dangers of PFAS and to try and establish strong rules to regulate them. One of the things that we are working on is to get municipalities to test their drinking and wastewater for PFAS before the unregulated contaminant rule by the EPA goes into effect. The Biden administration has set aside $10 million for this for unregulated contaminants. 29 out of 30 are PFAS. And so if your municipality tests before 2023, when these funds are released for people or for municipalities to get grants for testing and for remediation, you will be likely to get one. That amount of money is not going to last long because this hazardous chemical is everywhere. When you have your municipality test for their drinking and wastewater for PFAS, we would like you to pass that information back to Move Past Plastic so that we can pass it on to other organizations who have maps, some of which you will see, so that this information can be shared with everyone. This will help us establish good legislation moving forward to protect all the citizens in the United States. One of the things I attended just recently and a few weeks ago was the National Academy of Science, Engineering, and Medical Board. It was a 4-day conference where they focused on chemicals and their impact that they particularly have on our children, infants, and fetus in utero. One of the things that was very surprising to me and shocking was just how much chemicals are being produced and we are being exposed to in our youth and babies are being exposed to. It equates to 30,000 pounds per person in America. This is a lot. Very few of these chemicals are tested for safety. In our country, we kind of have regulations where industry can test for the safety of a chemical and disclose that, and then it will be regulated. PFAS is one such chemical among hundreds and thousands of chemicals where they are used just like lead and asbestos was for decades without any regulation, even though they were known contaminants by the industry. The Stockholm Environmental Institute has declared that we have chemical and plastic pollution may be exceeding the planetary boundary. The reason why they're saying this is because there are so many chemicals and plastic all over the world. There is not a single place on the planet where PFAS, microplastics, and their harmful chemicals are not present, from the Pyrenees Mountains, Antarctica, and the ocean trenches. The Nordic Council of Ministers has shown that there are 144 known hazardous chemicals that are used in plastics. PFAS are one such chemical. However, there are over 10,000 of these retardants, hardeners, softeners, lubricants, phthalates, biophenols, and stabilizers used in plastic that are not regulated. In fact, the ETH of Zurich researchers found 2,400 chemicals that were bioaccumulating and persistent in our environment, in our water cycle, air, and soils. Of those 2,400 chemicals, 900 of them alone are used in food packaging and exposing us to these harmful chemicals. So let's get into what a PFAS is. A PFAS is a per and polyfluoroalkyl substance. It was created around 1930 by 3M and then DuPont, and it was created to resist heat, oil, and water. Those are fantastic qualities that we need in many of our products. However, they are hazardous and being used in non-essential products where we have other alternatives. Because PFAS are made from a carbon and a fluorine bond, that is the strongest bond in chemistry. This makes them not break down in nature. So all the PFAS, there are approximately 9,000 different types of PFAS in the class that have been created for almost a century now, and more are being created. So they are not breaking down in our environment, and they are circulating in our environment, accumulating in our food, in our water, in our soils, in our air, and a part of the water cycle. It is literally raining PFAS on us to up to and more than 1,000 parts per trillion in some areas, and microplastics. Microplastics also act as a vector for absorbing toxins and transporting them and invasive species. Where do we find our sources of PFAS? Well, predominantly from the oil and gas industry. Think of fracking that well. You've got heat, water, and oil that you want to, protect your machinery, equipment, and everything from. And so PFAS are used heavily in that industry. These PFAS end up in our waste management. I'll talk more about that in a little bit. You find them heavily in chemical manufacturing, and plastics are heavily laden in PFAS. When the nurdles go through the extrusion process, they don't want that to gunk up to make the molds of whatever plastic is forming, and so they put PFAS to avoid that process, as well as the actual plastic that's being made has PFAS in it. It's heavy in electronic industry, metal, printing, and it's found in our airports. Here are some common everyday products that expose the average citizen to the harmful chemicals. As I mentioned before, they're extremely prevalent in food packaging, especially takeout packaging. But they're in your waterproof mascara, they're in your fishing line, they're in printer's ink, they're in clothing, your tents, your waterproof shoes, gloves, you name it. We are exposed to so much, microchips, anything electronic. They're also found in tires and carpets, those water resistant carpets with Scotch Guard, lots of PFAS. So one of the exposures that we are really getting exposed to, and it's another campaign that Move Past Plastic is working with, is to try and share the hazards of artificial or synthetic turf to your school boards and to your municipal park systems. The artificial turf is so dangerous and hazardous. Lead is ranked among one of the top 7 exposures for lead for youth comes from artificial turf, as well as heavy metals such as mercury and cadmium, as well as many other toxins, including PFAS. So PFAS not only harm youth that play on these fields, from tire crumb to artificial grass, giving them second and third degree burns, lacerations, stressing their ligaments and tendons, but they are also impacting our waterways, our watersheds, contaminating our environment and making a completely sterile ground for generations. And they have to be replaced every 7 to 10 years. They also get 30 to 50 degrees hotter than a natural grass playing field. So we've talked about most of the sources of PFAS. Another really big source of PFAS is for firefighting foam and products that we want to prevent from catching on fire, from clothing to our construction materials. All of these products end up contaminating our environment. They go into our landfills. Landfill leachate gets collected, brought to our wastewater treatment plants. And then that wastewater is not, the PFAS are not, as well as other hazardous chemicals, are not filtered out of that. But that goes back into our creeks and into our watersheds where we draw our water from, and aquifers, as well as the biosludge. It heavily accumulates in that. That gets spread on our agricultural fields. And then the plants and the soils absorb those PFAS and other chemicals, and then animals eat them. We eat them, we eat the animals. And so you can see this whole bioaccumulation process happening. And then it just continues on. So what are problems with health? Well, these are some animal studies that have been agreed upon by EPA, CDC, and Food and Drug Administration, that there is a direct connection of PFAS to many cancers, altered breast development, depressed immunotoxicity, meaning that COVID vaccines and other vaccines are not as effective. It also has, these are some adverse health effects by just plastic in general because of all the chemicals. So you could see the carryover from that and PFAS and the connection. Here's human studies that have been agreed upon. Now, these are not all the health hazards that are being connected with PFAS. A lot of research has been happening over the last few years, and even more and more studies with our youth and our infants. So everything from autism could be caused by PFAS and increasing eyesight problems, into developmental delays in body and in the mind. So there's a lot of health hazards from PFAS. Microplastics, nanoplastics, PFAS, and the cocktail of chemicals that we're exposed to are crossing into the unseen. So the unseen in our water, in our environment, in the food we eat, in our infants and our fetuses. It's in mother's breast milk, it's in the bottles, you know, a formula that we give our infants. It is everywhere. You can see here the small macroinvertebrates, which are the larval stage for different insects and that are part of the food chain. And you can see the plastic, but the chemicals are with them. And they go into these fish and to us. And like I said, it's literally raining plastic and PFAS on us. So let's get into what is being done about this very toxic chemical. Well, around the year 2000, there was a big lawsuit because they ran one of the largest epidemiological studies that had 69,000 participants that showed a direct causation of PFAS to some of those hazardous health harms that I showed you in the earlier slides. But in spite of that lawsuit and many more after it that were successful in making the connection of the hazards of PFAS to human health, EPA and TOXA, other organizations did nothing to regulate this harmful chemical. Before 2016, there was a 4,000 parts per trillion health advisory. After that, there was a 70 parts per trillion health advisory. That is a non-enforceable statement is all it is. There's nothing that, it's not a regulation, nothing that could be enforced for our health safety. So because of this, states began to start making their own regulations. Just for point of reference though, EWG say 1 part per trillion or less is safe. So what is 1 part per trillion? It's kind of hard to wrap your head around. It's equivalent to a grain of salt in an Olympic-sized swimming pool. Just that much of this toxic chemical can be harmful to your health. Now, this is a bioaccumulating chemical, so it's not instant. You're not going to die. It's going to affect you over your lifetime exposure. So they want to have less than 1 part per trillion over your lifetime exposure. Just recently, the EPA in June of 2022 put a new health advisory of basically that non-detectable PFAS limit. This is what they are proposing. It's going to be going up for public comment, and we hope you make public comment that not only should they be having the regulation for 2 of the most highly used and studied PFOS, but the entire class of PFAS to make those non-detect. We don't need any of it. The next generation short and ultra short chain PFAS have been found to be equally as hazardous. In fact, they almost are worse because they don't just reside in the blood, they get in our organs, and because of their smaller, shorter nature, instead of staying in the soil, they actually get into our water cycle more and are harder to get out by the different current methods that we have of removing PFAS. So what can we do about this? Well, $10 billion by the Biden administration have been set aside for unregulated contaminant chemicals. There are 30 of them that are in this group. 29 of the 30 are PFAS. So this is why Move Past Plastic is urging you and your municipalities to test their drinking and their wastewater. If you can get your drinking and wastewater tested, which will cost you less than $2,000 or your municipality to do this, I'm sorry, that's for your drinking, and then wastewater would be an additional. But that would give you data to be able to claim the grants and request the grants for the unregulated contaminant rule, and to have access to some of that $10 billion. It sounds like a lot, but like I told you, PFAS are prolific and found everywhere. And so that money's not going to last long. So some states had put some regulations on 2 to 6 of the current PFAS that are highly used, and at that non-detect level or a little above. So you'll be getting a map to see what kind of regulations your state has put in. So there are 11 now. Pennsylvania just went through public comment in April and May. And so other states are also getting on board. However, it's going to take at least until 2024 to 25 before those regulations go into effect and become enforceable. So meanwhile, it's very critical that your municipality knows, does it have a problem? So Pennsylvania has their public comment where they wanted to set a maximum contamination level for those 2 most common PFAS, the PFOA and the PFOS, and 103 sites and 112 sites out of the 412 that were tested did have those 2 chemicals in them, as well as other chemicals. There were 2 sites that had above the 70 parts per trillion, and there were 8 PFAS out of the 18 that were tested that were detected. So the maximum detection levels you can see here, and some of them, you know, were quite high. However, we don't really care about maximum detection. Averages, which you can see up here, aren't too bad, right? Oh, whoops. Let me get back out of that. And oh my goodness, I'm going in circles. Pardon me. Let's try this again. Okay. So you will be given a toolkit, which is going to give you all the information you need to be able to go to your municipal leaders, or for municipal leaders to use to know how to go about getting their drinking water and wastewater tested. This is one of 2 maps that I'm going to share with you that will help you find potential contamination sites. So you'll want to know these potential sites, because if your drinking water and wastewater come back that they're, you know, high and have PFAS in them, you will need to figure out where this contamination is coming from. So even though it is raining down on us, oftentimes point source versus non-point source like rain is where we're going to get those higher level of PFAS concentrations. We're going to go over the different locations here in a minute, but landfills, as we mentioned before, are where all the electronics and the plastics and things, items with PFAS gets dumped. So it accumulates in there and in Lecce. Here where I'm from, there are 2 big landfills. This is one of the maps that we'll be going over. This is my borough here, Carlisle Borough. You can see it is showing about 10 potential PFAS contamination sites. It's not saying that those sites are exposing the residents to PFAS. It's just that PFAS are used at these sites, and there's that potential. This is the Contaminant Creek, which the many of these municipalities draw their drinking water from, and their wastewater plants are along this creek and can be contaminated. Now, you have airports, landfills, technology, and military sites. Those are your four big industry locations where you can find heavy sources of PFAS use. And that's what the map will refer to. Now, bear in mind that map is just going to be showing you the most up-to-date of those. So the current airports, military bases, landfills, and industry. It is not going to show you legacy or past of any of those. And those could be potential sources for contamination. So remember I told you that tires are very high in PFAS. Well, in my area, we had this tire and rubber industry for many, many years. This is a current industry, technological industry that is in my township. We had 4 old legacy landfills that those tires, and another industry, we had carpets and Maslin Associates that dyed carpets. Remember I told you that it was also ink was very high in PFAS. Once again, the jets that are spraying it need to stay clean and not gunked up, resisting oil, water, and heat. This was a place where the tires were dumped and carpets. That was a part of our borough, but it's now in a different township. So that's something else you have to be careful of, is political boundaries might have changed. Here is a primary stream that is running into the Contaminant Creek, which is where municipalities along this 109-mile stretch get their drinking water. So there's probably 100,000 residents that get their drinking water from this creek. I call this creek Ferris-Monera Creek, and it represents many thousands of small primary tributaries that are unknown, not mapped for possible contamination. So this is iron oxidizing bacteria. I do not know, we do not know if those tires are leaching harmful PFAS into the drinking water for the townships downstream. So it would be a good idea that this gets tested. I'm not saying it is contaminating and has PFAS in it, but we don't know, and it should be investigated. So look for these types of past legacy industries and waterways in your system. We will be going over watershed maps also. So you can go to EWG, the Environmental Working Group, to look and learn about how to avoid PFAS chemicals in your daily exposure. The toolkit will give you lots of resources and walk you through how to do that as well. What are some current solutions to this PFAS crisis? Well, most of them deal with trying to clean up PFAS from a point source, which means a particular location, a landfill, an industrial site. They won't deal with the raining or a big agricultural spread But they're also expensive and they take a lot of energy, and they collect PFAS, which get taken to the landfill and get reintroduced into this bioaccumulating cycle. But on the horizon, there are at least 3 different researches that are coming out where they're basically taking off the head of this chain, carbon and fluorine chain, and breaking that off through different methods of just basically using lye and some other methods. They're collecting the PFAS and then taking off those heads. So that's kind of exciting, and there's links in there to learn more about that as well. So in the live session, I had question and answers. There were so many great questions from the different presentations, and please reach out to me if you have any of your own. This is how you can contact movepastplastic.com or contact me through movepastplastic@gmail.com. Please become a member to get emails and updates of what we're working on and the PFAS campaign and the updated toolkits, etc. And go on to our social media, and thank you so much for coming. All right, so now we're going to move into introducing you to the toolkits that you're going to be given. Let me share my screen. Okay, this is the Engaging Municipalities to Test Drinking and Wastewater PFAS Toolkit. Has Move Past Plastic information. So if you have questions, concerns, additions to this toolkit or the others, you can reach out to me. And if you need help with engaging your municipality, you can reach out to me. So we have our table of contents here. So the first thing you're going to come across is you'll see in the 3 toolkits that you'll get is that we have a section right at the top of them for Spanish speakers, and it has some resources. Now, it's not as comprehensive as everything I have here, but it definitely gives them a good start to understanding the PFAS crisis and some things that they can do. Within this toolkit, you will have links to the PFAS Talking Point Toolkit and the Media Toolkit. The PFAS Talking Points Toolkit is to be used for kind of isolating areas of concern that you might be dealing with. If you live near a military base and that's where your point source PFAS contamination is coming from, you'll want to go to that section. But there's also sections on agriculture, biosolids, waste management, general health, prenatal and children's health, general PFAS, further information on it. You can use these talking points if you are writing a letter to the editor, reaching out to your legislators, or needing to speak to your municipal leaders and or community members. You'll also have the recording that you're listening to here, and you will have the PowerPoint slides as well. From there, you see the state by state regulations and know what kind of regulations have been put in place, and be able to, you know, sign up for if there's more public comment and you want to weigh in on adjusting the maximum contamination levels. Remember, we want non-detect as a class of PFAS, because otherwise it's like whack-a-mole. You're just shutting down 2 to 6 of the 9,000. So here's a map. That's a nice, good visual of where we're at currently. All right, then we get into building your directory for your stakeholders who you need to gather to bring to the table to get your municipalities to say, yes, we're going to check our water and wastewater for PFAS. So we have watershed specialists that you might need to reach out to, your municipal governing leaders. Every municipality statewide, within a state, and no less state to state, is going to be very different. So these are just stereotypical titles and positions that you can look at and look into. We also give you some pointers of what are your initial questions to ask and who to reach out to. What is an MS4 coordinator and that kind of thing. The potential sources of PFAS contamination. We talk about the 3 different types of public water systems. This just kind of outlines the different types of places that you have contamination: military bases, airports, landfills, HSCA sites, Superfund sites, manufacturing sites, and don't forget the fire training sites. Firefighting training sites. Also not on here is included fracked wells, right? That's big, big, big fracked wells. I need to add that in there. I wonder if I can type while you guys are here. Yay, I can. Like I said, this is a living document. I know I have this fracking information somewhere in here. I think it's in the Talking Points Toolkit. Okay. Then we have a graphic for you to see the PFAS cycle, and that's a good image to pull up for your municipal leaders so that they can visually see and understand what you're talking about with the PFAS cycling and bioaccumulating. We're going to be going to this map momentarily that's going to show you potential current sites of contamination. So not our legacy landfills, military sites, wells, or industry, but current up-to-date ones. I'm also including a map of the landfills in particular and projected landfills, because maybe you don't want a new landfill coming where you're at, or you want to monitor your landfill for fracking waste full of PFAS and TNORM and other, electronic waste, and that's super high in PFAS, right? We'll go over these watershed maps. It's very, very important that you understand what a watershed is. When you know what your watershed is and you know where the water is going, you can find those, cross-reference the maps for the potential PFAS contamination, and you can see if there's water drainage of any of those primary streams, secondary streams that are draining into your potential drinking water or wastewater areas. We'll be going over those in a little bit, and I kind of tell you how to do that. Then we go over labs that can test from everything from blood plasma, which it's in 99% of all humans, I'm guessing, animals in general, and it tests for water, drinking water, and waste and soils. So the 2 labs that I really like are PACE and Eurofin, but there's some others in here as well, ALS and enthalpy, and more labs are popping up. They're very expensive, about $100,000, $500,000 to set up a single lab testing unit for PFAS. So they're gearing up quickly. Lots of things have changed in a short time. So then here, how to test solid waste, leche, and landfills. Sources for free well testing. More of that is coming around the corner. So check your states. Some places that you can check are your extension office, conservation office, etc. We have also in here your sources of PFAS and ways that you can safeguard yourself and your home from sources of PFAS. We have what products to avoid by the Environmental Working Group. We have home drinking filters and which ones are good and not good and what do they filter. Basically, most all of them, if they filter PFAS, it's just PFOS and PFOA. That's it. They don't filter any of the other ones, and they don't filter next generation PFAS, because like I told you, those are the short chain, ultra short chain, and they just go rampant in water. So the best filter is truly reverse osmosis. But even that, no matter if you get the carbon, the charcoal filters or the reverse osmosis, you have to change your filters regularly. Otherwise, you actually build up a bioaccumulation of PFAS to ingest. Let's see, what do we have left? We have treatments, current treatments for PFAS. And so you can see them all here. Activated carbon, like we use in our home filters, and a bunch of others. Remember, these are just collections for PFAS. They don't destroy them. So then when you collect them, they go to your landfills, and then they go to your leche, and then your biosolids, and your agriculture fields. So this is not ideal. And remember, it costs lots of money, energy, and only deals with point source. But it's better than nothing to start with. However, good news is around the corner. There are some, I give you a bunch of companies and some more details on that. There are some companies, like I said, that are some, there is some science in the works for dealing with PFAS by getting rid of them, breaking their bonds and not letting them be in the environment. This also leads you to the unregulated contaminant rule and some links of how you can apply for grants if you find out you have higher PFAS than you'd like and you want more money for further testing and to do remediation. This is where you're going to go. We also have I don't know how to pronounce that acronym, ASTERD and SWANA. The EPA's PFAS strategic roadmap is in here, and EPA research for investigating the effectiveness of point of use and point of entry removal systems is in there, and some other things, and then some more specific information for Pennsylvania. References, my contact information at the bottom as well as at the top, and references. So that wraps up your toolkit. Remember, it's a living document. You can help me build it and contribute it. You can help take on, or anybody else can help me make it pretty so it's not so messy looking. Hopefully it's not awful, but it could be improved for sure. And we need the latest information and the latest data at all times. So you're welcome to help me with that and reach out to me. So thank you so much. We are going to move on to our mapping. All right, so let's go and look at some of our maps. Okay, this first map is by Argus. You're going to click in the lower left, I understand, then okay. It gives you your keys that you can use, and it's mentioning the PFAS, that there are 9,000 highly persistent toxic chemical substances, and a little bit about them. Okay, so then it brings you to this tutorial, which we're going to skip because I'm going to go over it with you. And basically you just click outside of that highlighted box, and then that will bring you to the map. From this map, you will type in a zip code, and it will start off with showing you the known contamination sites. So it has one known contamination site with 0 to 10 PFAS present. Now remember, in Pennsylvania alone, it's one of the states with the most waterways next to Alaska. They only tested 412 sites. So it's doubtful that there will be known sites up there. Most of the known sites are going to be your military bases, which almost all of them have PFAS in excess of the health advisory that was just there a month back of 70 parts per trillion. A lot of those bases have thousands of parts per trillion and hundreds. Another place that you that you will find contamination for is airports. So military bases, airports, industry and primary electronics, tires, paints, and you will also find it in the waste management. So those first 4 that were on that bar map that I showed you. So I've just now clicked up in the top, we were at known to suspected contamination. If you go to the layering below the magnifier, you can select all of them, known, suspected, and tribal, whatever you want. All right, it shows you which colors, the legend over here on the right, which colors correlate to what type of industry or military base or airport. You can go in our wastewater. You can go and click on any of them, and it will give you more information about it. So this one is the Carlisle Barracks. What's interesting, I find, is that the information that was here 6 months ago that told me 37 parts per trillion, do not quote me, but I believe it was for testing for 2021, showed 37 parts per trillion. For some reason, it also just 14 miles up the creek at a naval base showed 37 parts per trillion. Now, for some reason, that data is gone. I do not know why. It was there, it's gone. It's also gone from the EWG. So obviously, the United States has seen fit to remove any data showing the very toxic military sites with PFAS. Not great, but you can at least go in and find where potential sites are for PFAS contamination. So they also have some community resources and state action that you can click on. We're going to move to the watershed mapping in a moment, but there's another map that you will be given, and this map will contain the different landfills and energy sources. So that will tell you more about possible contamination. So we can click our zip code in there and take a look at that. So we have one thing coming up, and let's see. Okay. All right, so here is a landfill right here, and that's Cumberland County landfill. Remember from the one slide we had 2 landfills, and this is one of the 2 in this county. You can see the other one is right here, I believe, in Chambersburg. So there are 2 landfills. So you can use this map and this map in conjunction with these watershed maps that we're going to look at. Oh, you'll also be given this. This is a projected landfill, which is very important too, because we're creating more and more waste every day, and waste land management areas get filled quickly and they have to find new ones. So you might be interested in where they're planning to put the next one in your community. All right, so this is My Waterway by EPA. It is a wonderful, wonderful resource. So let's put in our zip code. Okay, so the first thing I like to do is go and select what I want to see. I like to pick imagery hybrid. And then I like to know my discharges, identified issues, watersheds, county. And I also picked in this shutdown my urban heat island. But you can do flooding as well. The reason why the flooding and the urban heat island are good to layer is because if you have a source of PFAS, and the heat islands will tell you where there's impervious surface or pervious surface. So in impervious surface, the PFAS are going to run off of it down to a lower lying land where you might get your drinking water. A pervious surface, though, if that PFAS contamination was there, would be going down and absorbing into the soil more and possibly into an aquifer or a well, nearby wells. So the flooding is good because that also tells you about those surfaces and where water is going to run from point A to point B. And look at that. So a watershed is an area of land that drains into a point, a river, lake, or the sea. Think of your basin. Watersheds are often called basins. So it runs off from your sink down to a drain. The drain would be the river, lake, or the sea. So this is why it's important to understand where our waterway is, or what a watershed is. This particular watershed map is going to map the smallest watershed address. A watershed address is, think of the Russian nesting dolls, smaller one and then the bigger and bigger and bigger. Or your street address, you have your house, your street, your city, your county, state, US, country, okay? So it's the same with watersheds. You have your smallest watershed, which is a HUC 12, and a HUC means the hydraulic unit code. And to what we like to use that's a little bigger is HUC 8. So this is going to give you your smallest watershed address. All right. From here, we can, let me come over here and go to the overview. All right. Whoop. Okay, so we're in the overview. In the overview, you can see that this watershed has 19 water bodies, 21 monitoring locations. Let's click those on, and 9 permit discharges that come on in a yellow square. These are very good to know because you can see if they're monitoring for PFAS in a potential PFAS contamination site, near a site. And you can also see if there's an industry or someone is discharging into the water, if they are a potential contamination site if they're discharging. So you can go back and forth between your maps. So you're over here, and so you could go, okay, well, right here is, here, let me zoom in a little bit. Okay, this is a, whoops. Okay, this is Tyco Electronics. Are they discharging into the stream? And then you'd go over to your other map here, and you could see if that's the case. So you could see who's discharging here. And this one is a discharge of Mechanicsburg, not sure, WWTP. And then they'll tell you if they have any violations or they're in compliance, and you can look at their report. Okay, so you can go back and forth like that. You could also see what is being tested. Okay, so you can click on, let's just do this one for kicks. So this said that this is impaired water for aquatic life and fish, and it's because of PCBs and sediment. And then you can view the water quality report. You can also open up any of these as well to look at contamination. All right, so this is a well by USGS monitoring well, and you can see what they are looking up. So they're looking up for nutrients, metals, and physical characteristics. Let's take a look at all right, this monitoring station is monitoring 109, or they've done 109 samples, monitoring for 437 measurements for sediment and physical. Here we have nutrients, metals, and physical, PCBs, toxic organics, PCBs, sediment. I'm just clicking this arrow to go along. Okay. One of these I clicked into, I'd like to find it. They actually are testing for PFAS, monitoring for PFAS. Okay, here it is. So here they're testing for 5 different PFAS. So that's good to find out. Once again, are there being any tests done for PFAS near a potential contamination site? So that's how you use these maps. So another thing that you're going to want to look at is up at the top here is you're going to want to, you can see by clicking on any section of the stream how it is being impacted. So it will tell you, hold on just a minute, scroll down. Okay, so this is going to tell you that it's impaired for aquatic life and fish consumption and why. But you could also get that information by clicking these over on this side. We're going to move on to drinking water. The drinking water tab is really good because it shows you the political boundaries. So with the HUC 12 watershed boundaries nested in it. So that's really important because you want to know what watersheds are within and what towns are within different nested watersheds within their county. That will tell you that in this county there are 104 different public water systems, or PWSs, and it'll tell you what they are and if there are problems. So you can click on it and it tells you how many it's serving, 30,000, and that there's no known violations. Remember, however, there are hundreds of chemicals that are known to be hazardous that are not being regulated. Therefore, they're being tested for, but it won't come up as a violation. EWG Environmental Working Group has area that will tell you these hazardous chemicals, and you can cross-reference besides PFAS and cross-reference to see if they're high in your public water, and if they are, it's something you might also want to address along with the PFAS contamination. It tells you who draws the water and which waters have been assessed for potential drinking water. There's your monitor tab and identify issues, restore, and protect. So you can see what's being done. What have they fixed? What issues do they currently have? So this is a fantastic resource. Within there, you can also click and get the information of different chemicals that and violations that may have happened or are happening. We're going to move on to Model My Watershed. This is another great resource that lets you get that bigger HUC 8 size watershed outline, which is important because like that one primary tributary that's coming down and potentially contaminating the townships and the municipalities to the east of that drainage, right? Even though mine is safe, you'll be able to see that, because that way you could see if your, you know, potential sources, which water, which municipality they're going to potentially impact. Okay, so I like to go to continental high resolution layer here, and that was right there. And because it'll show you the most streams. So it's still going to miss, like I said, thousands of those primary streams, but it's still better than nothing. And then I like to use land cover usage is a good one to click on. And this is my HUC 8 boundary here. And I have to shrink to get that to populate for you. So you could see this is my HUC 8. So it's pretty much following the Cumberland County, PA, but you could see this is the big watershed here, the Connedaguinet Creek. But the Connedaguinet Creek starts in another political boundary, right? Another watershed, it like diverts between here. But you can cross-reference this to the different political boundaries from the other map we were just at. It will show you the smaller watershed boundary, the 12, and you can see how they're like linked, interlinked, the different smaller watershed boundaries. This is the one we were, the HUC 12 that we were just looking at in the other one. Okay, so once again, this is good, so you could just work with your other community members to see where things are traveling. The last one that's just kind of fun and just gives you like this overview of how things look in your watershed and how land is being used. So what I just put in is going to show up right there, and that's what it's going to take you down that path. So it's just kind of fun and neat. It's called River Runner. So you can see how the land is being used along this water body where people are drawing their water from. All right, I am going to stop here. All right, everyone, thank you so much for sharing your time and wanting to learn more about how to get your municipalities to test their drinking and wastewater for PFAS. If you have any questions, please reach out to me, Tamala Trussell, at movepastplastic@gmail.com. Go to the website, www.movepastplastic.com, or reach out to us and see what's happening at social media. If you have any questions, comments, or concerns, just let me know. Bye.